Let's talk about an invisible shield. Seriously, it's built into our electrical world, a single rule buried in the huge national electrical code that you've probably never even heard of. But it's there, and it works silently every single day to prevent absolute disaster. So, let's dive into NEC Rule 215.15.
So let me ask you something. You're working on some equipment, you head over to the main disconnect, and you throw that big handle down to off. The machine powers down, you're safe to work, right? Well, the answer is a little more complicated and honestly a lot more dangerous than most people think.
I want you to picture this. It's a scene that plays out in factories and buildings all over the place, every single day. A maintenance tech needs to service a motor. They do everything by the book, go to the panel, throw the disconnect switch, kill the power. They swing open that cabinet door, feeling totally confident that everything inside is dead. But it's not. And here's the hidden trap. Inside that same cabinet, just inches from where their hands and tools are about to be, some of the conductors, the ones that are upstream of that switch, are still fully energized. They are live, they're uninsulated, and they are just sitting there, waiting for an accidental touch. See, that off switch only killed the power downstream to the equipment.
So, where is this rogue power coming from? Well, the first culprit is something called feeder taps. The best way to think about this is to imagine the main power line as a big electrical highway. A feeder tap is like a little exit ramp that pulls power off for something specific. And the crucial part is, this exit is often located before the main off switch you just flipped.
The other common source for this hidden hazard is transformer secondary conductors. These are simply the wires coming right off of a nearby transformer. And just like those feeder taps, they can get wired into the panel before the main disconnect, which means they stay hot no matter what position that switch is in.
So what you have now is a perfect storm for what the code calls inadvertent contact. And let's be clear, this isn't about someone being careless and grabbing a live wire on purpose. No. This is about a wrench slipping out of your hand. It's about your arm brushing against a terminal while you're reaching for a tool. It's a small, totally unintentional accident that can instantly lead to a deadly shock or a massive arc flash.
Now, this is not just some theoretical problem. They often say that safety codes are written in blood, and this exact scenario is why the experts created a specific rule to act as a shield. So let's look at the solution. National Electrical Code Section 215.15.
Okay, I know. That is a mouthful of legal and technical jargon, but trust me, every single word in there is important, and the idea behind it all is actually brilliantly simple. Let's break down what this thing is really telling us to do. We're going to tear this rule apart, piece by piece, and see how it creates this little bubble of safety exactly where it's needed the most.
You can really boil this whole rule down to 4 simple questions. What is it? It's a physical barrier. Where does it go? Inside all that common electrical gear. The big metal boxes that hand out power. When does it matter? Specifically when that main switch is in the off position for service. And the big one? Why? To physically block you from touching those live feeder taps and transformer wires we were just talking about.
At its core, this rule is just demanding a simple, non-conductive shield. It's not a fancy electronic system. A lot of the time, it's literally just a piece of plexiglass or some other tough plastic. It is a physical wall, put there specifically to separate the worker from the parts that are still hot.
All right, so let's put it all together. Let's see how this simple little piece of plastic can be the difference between a routine maintenance job and a life-changing accident. Okay, so here's the safety sequence in action. The tech opens the disconnect, the load side goes dead just like it's supposed to. But those upstream conductors are still live, and that's where the magic happens. That barrier the code requires is now physically standing between the worker and those live parts, which makes that accidental contact pretty much impossible. It's prevention, not reaction. And I mean, the difference is just night and day. Without that barrier, you've got live terminals just sitting out in the open in the work area. A slipped tool could be fatal. With the barrier, those exact same terminals are shielded, and the risk of that inadvertent contact is basically gone. The work area is now actually safe. So why spend all this time on one little rule about a small piece of plastic? Well, because this simple barrier is the perfect example of the whole philosophy behind modern safety codes, which is to engineer the hazard right out of existence.
It's all about being proactive. This isn't just some line in a book. It's a lesson learned from past accidents, written down, and then built into every new piece of equipment. It's one small piece of material required by one clear rule that prevents a very specific, life-threatening danger. It really is an invisible shield, just doing its job.
And that kind of leaves me with a final thought for you. The National Electrical Code has thousands of rules, just like this one, and every single one is designed to see a specific danger and stop it before it happens. It really makes you wonder, doesn't it? How many other invisible shields and unseen protectors are built into the world all around us, just quietly keeping us safe every single day?